And then I'm going to end on what I think is going to be the legacy of Cassini and all our interplanetary explorations. So we start with the planet. There's the screen.
Beside you.
Beside me. Oh, over there. Okay, they can explain this to me. So, okay, so we start with the that's Cassini entering the atmosphere. December 2010, we saw a major meteorological event in the life of Saturn occur while we were there. This is the birth of a colossal lightning-producing, thundering storm that we watched be born, develop, spread all the way around the planet until the tail met its head and then eventually fade. This is the kind of storm on Saturn that happens every 20 or 30 years. We're tremendously lucky to be able to be there so that we now can study what it means and what it tells us about the atmosphere of Saturn. At the North Pole, we found in extreme false color, we found this enormous vortex, larger, well, half the size of the US, and very much like a hurricane here on Earth with winds that blow 330 miles per hour, and just a major feature. And it's observations like these that tell us about what is different and what is the same between a giant planet atmosphere and the atmosphere that we have here on the Earth. And they hence equip us to be better custodians of our own planet. Of course, the rings are what makes Saturn the glorious, iconic planet that it is. They are very large. They would slot in nicely between the Earth and the Moon. They consist of countless icy bodies, the largest are as large as houses. They're in independent orbit around the planet, and the rings contain an enormous amount of structure. A lot of this structure, especially in the outer portion of the rings, let's see, well, I can't point to the screen because I can't see it, but in the outer portion of the rings, much of the structure that we see here is induced by gravitational perturbations with moons, either external to the rings or embedded in the rings. And these features, the structures, some of which were discovered by Voyager, were expected, obviously, and we found more, and where with Cassini information, we're learning a lot more about them. But we saw things in the rings that were wild and totally unexpected. And one, the next picture, I can't point, but at the outer edge of the brightest ring, the thickest, brightest ring you see there, that's the outer edge of the B ring. It is anchored by the strongest resonance in Saturn's rings, and there we saw this crazy stuff. We saw these mountainous, vertical spikes of ring rubble betrayed by their shadows on the rings. And these things just extend vertically up to 2 miles out of a disk of particles that's only 30 feet thick. Okay, that's something that should go into a science fiction movie. Okay, and this is because this is a region of very high compression where the particles are shoved together because of the resonance so much that they have nowhere to go and they splash upwards. And then we also found a class of objects, moonlets, in the rings, betrayed here by their propeller features that you can see dotting the ring, and of course there's also a very prominent density wave by the moon Prometheus. And these moonlets are anywhere from 10 meters to a kilometer or more in size, and we hadn't really expected to, I mean, we thought they might be there, but this was proof that there was sort of a larger end of the size distribution of particles in Saturn's rings. So these observations give us insights into the kind of processes that occur in disk systems like Saturn's rings that are common all throughout the universe, from protostellar disks all the way to the spiral disk galaxies. And then speaking of moons, Saturn has over 60 of them, and we've come to know a lot about some of them, and we've taken some amazing pictures in the process. This is Pan, a small moon, only 30 kilometers across. It's responsible for one of the gaps in Saturn's rings, and it has this unusual appearance because at the later stage, the last stages of its formation, it's embedded within the rings, the last stage of formation, it was accreting material from the very thin rings, and so all that material ended up girding the equator, and it gives us this very cartoonish tutu look. And then, of course, there's Iapetus. Iapetus is about 1,000 kilometers across, about a third the size of our moon, and it was discovered hundreds of years ago to be two-toned. One side of it is black, one side of it is white. And we have found with Cassini that this is the site, the home of a runaway thermal process, where regions that start out warmer than average become black over time because they lose all their ice, and the regions that start out cooler than average, whiter than average, become even more white because they collect all the ice, and it drives it to this extreme where you have very white and very black, and it looks, as you can see on small scales, it looks like a Dalmatian dog. And then, of course, there's Titan, which is Saturn's largest. It's 50% larger than our own moon. And until Cassini got there, I love giving this statistic, until Cassini got there, it was the largest single expanse of unexplored terrain that we have remaining in our solar system. And so that is no more. But Titan, we knew from Voyager days that it was enshrouded in haze and we couldn't see down to its surface because of that, but we were able to figure out in Voyager days that the environment, the surface environment of Titan, admitted the possibility that there could be bodies of liquid organics on the surface. And so we were very eager with Cassini to get to image the surface, to explore and understand its surface environment, and go in search of those bodies of liquid hydrocarbons. And for that reason, one of the main things that Cassini did in the exploration of Titan was to deploy the Huygens probe. We did this early in the mission. It descended 2.5 hours through the atmosphere, and it returned finally when it landed on the surface. This historic image of landfall in the outer solar system, like something out of a Jules Verne adventure. Well, we learned a lot about the surface environment on Titan from the Huygens probe, but we didn't see even a puddle of liquid organics, and that was left for the Cassini orbiter to do. And we eventually found over the course of the mission that the liquids on Titan have gone to the poles, and here is a lovely image showing a sun glint off what we now know to be the lakes and seas of liquid hydrocarbons here in the northern polar regions. We also see them in the south, but there's more in the north. So Titan, and we found, with a radar instrument, we found that the shorelines of some of these seas look like the coast of Maine. So Titan turned out to be as fascinating and even more so than we had anticipated. It is the only place in our solar system where we find liquid organics ponded on the surface, and in its geological complexity and its geographical diversity, it is rivaled in our solar system only by the Earth itself. So I am hopeful that one day we will go back to Titan and we will drop a scientific research vessel, otherwise known as a boat, into the northern seas of Titan. And that brings me to the object that I think has given us the most profound and the most exciting discovery of all, and that is the small moon Enceladus, shown here alongside Saturn, that now lying by the way of the rings, just showing you how thin they are. And you can see Enceladus is rather small, no bigger than Great Britain. And I want to emphasize for those of you from the UK, this is not meant to be a threat. Although I would hesitate to show this to the present US administration. But anyway, Titan, Enceladus, we found has more than 100 geysers gushing from its surface. They originate in a subsurface water ocean that is as salty as our Earth's. It's laced with organic compounds, and it has available free energy. In other words, it has all the formal signs of an extraterrestrial habitable zone. And for this reason, we are facing the goosebump-raising question: could there be life on this moon, this little moon? Could there have taken place a second genesis in the outer solar system in this moon? And could there be signs of life? Could there even be microorganisms in the geysers of Enceladus, most of the solid matter from which falls back down on the surface? Could it be snowy microbes on the surface of Enceladus? And some of us are so enthralled by this possibility that we are planning a mission back to Enceladus to find out, and hopefully it will be selected, but we'll see. And so that is it. Cassini is now over, and a major epic in planetary exploration has come to an end. But, you know, at its heart, Cassini, like all of our interplanetary missions to the planets and the bodies in orbit around the sun over the last 6 decades, has been a story about longing. A longing to know us, a longing to understand ourselves and where we came from. And despite all the beautiful images, 450,000 of them that we have taken over the last 13 years, there is one image that speaks of this longing better than any other, and it has a bit of a backstory, and so I'm going to tell it to you now. Back in the 1980s, I had the immense good fortune of hitching a ride on the greatest exploration of them all, and that was the Voyager mission to the outer solar system. And in that time, I came to know and befriend someone you will undoubtedly recognize, that is Carl Sagan. And he and I worked, we both independently actually, came up with the idea to take a picture of the Earth from the outer solar system that eventually became known as the pale blue dot picture of Earth. And it turned out that the actual picture wasn't what we had expected. It's not exactly the most beautiful picture. It caught the Earth without any stars around it, which was something Carl was hoping to see, sitting on a beam of light that was scattered in the optics of the camera. Well, ever since I became the leader of the imaging team on the Cassini mission, I had it in my mind to do this picture over again, only make it better. And it occurred to me somewhere along the line while I'm thinking about how to make this happen, instead of doing what we did with Voyager, and what every mission since actually has done, take a picture of the Earth and then release it to the world 2 weeks later and say, hey world, we took your pictures 2 weeks ago while you weren't looking. Why don't we tell the people of the world ahead of time that, you know, on such and such a date, your picture is going to be taken from Saturn, and invite them to go out and participate. Invite them to feel the cosmic love. Invite them to get a sense of what the solar system is like. You know, your picture is being taken from Saturn. How cool is that? So, in fact, that's what we did. We got Cassini to take another pale blue dot picture of Earth, and we sent out the word. We said to everybody at the time, the picture-taking window opens, comb your hair, straighten up, okay, go out, look up, think about the utter isolation of the Earth and the blackness of space, appreciate the rarity that it is among the planets that orbit the sun, think about all of life on planet Earth, and appreciate, just think about the magnificent accomplishment that this interplanetary salute between robot and maker represents, and smile. And so that's what we did. We got, people responded just exactly the way I hoped they would. We got comments from all over the globe, Europe, the US, Asia, Africa, everywhere, stating from people a feeling, describing a feeling of unity with all living creatures on Earth, and I was very pleased about that. So here is the mosaic that all of you have seen already. It shows Saturn and its rings lit from behind, and it shows the lovely blue ring created by the spray from 100 geysers coming from Enceladus. And if you look even closer, over the shoulder of Saturn, you see 1 billion miles in the distance, our own small, blue, fragile Earth, which, with the high-resolution camera on Cassini, becomes the Earth and the Moon seen for the first time from the outer solar system. So, I think there is something very powerful that we all feel when we see the sight of our own planet as it would be seen by others in the skies of other worlds. And I think it is that startling, shocking, uncorrupted view of ourselves as we really are, where we really are, that never fails to move us. And it moves me to think about evolution. For me, this is the picture where Charles Darwin and Galileo come face to face. Because it is a picture that was made possible by Galileo's first experiments with gravitation over 400 years ago, and it is a picture that shouts evolution. I look at this picture and I see our distant ancestors stepping down from the trees and walking upright for the first time onto the African savannas and pausing to look back at the forest from which they came. And I look at this picture and I see a species that is unrelenting in its pursuit of knowledge and brave and ardent in its longing to grasp the meaning and the significance of its own existence. And finally, I look at this picture and I can't help but see the very best that humanity has to offer. We are, without question, the troubled and warlike inhabitants of one tiny little dot of the planet, but it would behoove us to remember that we are also the dreamers and thinkers and explorers who took this picture. One world clear across interplanetary space to another, a billion miles of interplanetary space. And interplanetary isn't where we're going to end. We have just recently heard of a new initiative called Breakthrough Starshot, the brainchild of Stephen Hawking and Yuri Milner, who I guess is going to be here later on. And this is a project to send a tiny little craft propelled on beams of light all the way to Alpha Centauri to arrive there in the not too distant future and conduct our first reconnaissance of another star. And if the passage of Voyager into interstellar space in the summer of 2012 was our birth as an interstellar species, then arrival at Alpha Centauri will be our baptism. And to be so tiny, to be so small, and reach so far is what makes us the extraordinary citizens of our planet and our galaxy. And it is this pride, this perspective of ourselves that, for me, is, I think, the greatest legacy that Voyager and Cassini and Starshot and all our interplanetary explorations beyond our home planet will leave behind. How glorious will be the day when we can truthfully proclaim, in the words of Ray Bradbury, written in 1971 upon the insertion into Mars orbit of Apollo 9, the first spacecraft to orbit another planet, "We have reached Alpha Centauri. We are tall. Oh God, we are tall." Thank you.